Take a look at this plate. At first glance, it looks like wood. Run your fingers across the surface, and you'll feel natural grain patterns. Hold it in your hand, and it feels stronger than paper. Yet it isn't wood. It isn't paper. And surprisingly, it isn't plastic either. In fact, this plate was never cut from a tree. No forest was logged to make it. No pulp mill turned it into paper. No plastic pellets were melted into shape. Instead, it came from something most people never think about: a leaf. More specifically, a fallen palm sheath. Every year, billions of palm leaves fall naturally from trees across tropical regions of Asia. Most eventually rot on the ground. Some are burned. Others are discarded as agricultural waste. For generations, they were considered almost worthless. But today, those same fallen leaves are being transformed into plates, bowls, trays, and food containers that are finding their way into restaurants, weddings, supermarkets, and homes around the world. And here's the strange part. Unlike most disposable tableware, these products often contain no plastic, no glue, no resin, no chemical binders, nothing added to hold them together. That raises an obvious question. How can a dry fallen leaf become a rigid bowl strong enough to hold hot food? How can a natural material survive soup curry oil and boiling temperatures without falling apart? The answer lies inside the plant itself, because hidden within every palm sheath are natural fibers and plant polymers that spent years supporting a living tree. And under enough heat and pressure, those structures can be transformed into something entirely new. What looks like a simple plate is actually the result of a surprisingly sophisticated manufacturing process. A process involving agriculture, materials science, industrial engineering, sustainability, and one of the fastest growing industries in eco-friendly packaging. The product begins as waste. The factory turns it into value. And by the end of this story, you'll understand why some companies are replacing plastic with something that literally falls from a tree. Because the plate on your table didn't start in a factory. It started on the side of a palm tree waiting for gravity to do its job. Long before palm leaf tableware became a sustainable packaging trend, palm trees were already providing some of the most useful materials on Earth. For thousands of years, communities across India, Sri Lanka, Thailand, Indonesia, and other tropical regions used different parts of palm trees in everyday life. The leaves became roofing material, the trunks became building materials, the fibers became ropes, and in many rural areas, large palm leaves were even used as natural plates during ceremonies and communal meals. The idea wasn't new. What changed was scale, because for most of human history, these materials were used locally. A family collected leaves, cleaned them, used them, and eventually returned them to the soil. No factories, no global supply chains, no industrial production. Then something happened. Plastic changed everything. By the mid-20th century, disposable plastic products were spreading across the world. Plastic plates, plastic bowls, plastic trays, plastic food containers. They were cheap, lightweight, easy to manufacture, and incredibly convenient. Restaurants adopted them, airlines adopted them, event organizers adopted them. For decades, plastic seemed like the perfect solution, until the waste started piling up. Scientists began documenting plastic pollution in rivers, oceans, and landfills. Images of beaches covered in plastic debris spread around the world. Governments introduced restrictions. Consumers started demanding alternatives. And suddenly, manufacturers found themselves searching for materials that could replace plastic without sacrificing convenience. Paper was one option, but paper often required cutting trees. Foam products were lightweight but created their own environmental concerns. Bioplastics emerged, but many remained expensive. Meanwhile, something was lying on the ground beneath millions of palm trees. Unused, free, naturally renewable. Palm sheaths? Not the leaves themselves, but the thick base that connects the leaf to the trunk. As palm trees grow older, leaves naturally detach. The sheath falls to the ground. The tree continues growing. No cutting required. No harvesting of living tissue. No damage to the plant. Nature was already supplying the raw material. The challenge was turning it into a product. Entrepreneurs in South Asia began experimenting. Could these fallen sheaths become disposable plates? Could they replace plastic? Could agricultural waste become a business? The answer turned out to be yes, and demand exploded. Today, millions of palm leaf plates, bowls, and trays are exported every year. Restaurants use them. Eco-friendly brands sell them. Wedding planners choose them. Food companies package products inside them. Consumers who have never seen a palm tree may use products made from one. Yet the raw material still comes from the same source. A fallen sheath lying beneath a tree? The manufacturing process begins with collection. Workers travel through plantations and rural areas gathering naturally fallen sheaths. Unlike logging operations, no trees are cut. No leaves are removed prematurely. Only material that has already detached from the tree is collected. The sheaths vary enormously. Some are small, others are nearly a meter long. Some are light tan, others are deep brown. Every sheath carries unique patterns created by years of growth and exposure to weather. This natural variation is one reason no two finished plates look exactly alike. Each product carries the fingerprint of the tree that produced it. Once collected, the sheaths are bundled and transported to processing facilities. At this stage, they still look like agricultural waste. Dusty, uneven, sometimes covered with dirt or plant residue. Nothing about them resembles a finished product. But hidden inside those rough surfaces is something remarkable. A network of strong natural fibers that spent years supporting heavy palm leaves against wind, rain, and sunlight. Those fibers already possess impressive strength. The factory's job isn't to create that strength, it's to unlock it. And that process begins with something surprisingly simple: water. Because before heat can shape the material, the factory must first bring it back to life. When the palm sheaths arrive at the factory, they don't look like tableware. They look like something that belongs on a compost pile. The surfaces are dusty. Some carry traces of soil. Others show signs of rain, sunlight, or months spent on the forest floor. If you place them beside a finished palm leaf plate, it would be difficult to believe they came from the same material. But hidden beneath that rough exterior is a structure remarkably suited for manufacturing. The first step is cleaning. And unlike many industrial products, this stage relies more on water than chemicals. Workers inspect every sheath before processing. Damaged pieces are removed. Sections with cracks, severe mold, or structural defects are rejected. Only healthy sheaths move forward. The selected material enters washing stations. Large tanks and high-pressure spray systems remove dirt, dust, sand, insects, and plant residue. Powerful jets of water penetrate the natural folds and grooves in the sheath. The goal isn't simply appearance. Food safety depends on it. Anything that will eventually touch food must begin with a clean surface. Some facilities perform multiple washing cycles. Others use rotating brush systems to scrub stubborn contamination from the material. When the washing is complete, the sheaths look completely different. The natural grain patterns become visible. The colors become richer. Each sheath begins revealing its unique texture. No two are identical. Unlike plastic products manufactured from molds, every palm sheath carries natural variations created by the tree itself. Those variations eventually become part of the finished product. But the material is now saturated with water, and that's a problem. Because the next stage depends on carefully controlled moisture. The cleaned sheaths move into drying areas. Some factories use solar drying. Rows of sheaths are arranged under sunlight where warm air slowly removes excess moisture. Other facilities use industrial drying chambers that accelerate the process regardless of weather conditions. The target isn't complete dryness. That would make the material brittle. Instead, manufacturers aim for a moisture level that allows flexibility while preserving structural integrity. Too wet and the sheath won't press properly. Too dry and it may crack under pressure. Finding the right balance is critical. Once dried, the sheaths enter sorting stations. Workers separate them according to size, thickness, shape, and quality. Large sheaths may become serving trays. Medium-sized pieces may become dinner plates. Smaller sections may become bowls or snack trays. Every piece is matched to the product it can best produce. And this is where the process becomes truly fascinating. Because until now, the factory has only cleaned and prepared the material. The transformation hasn't happened yet. That moment arrives inside the heat press. At first glance, the machine looks similar to industrial equipment used in metal stamping. Massive steel molds sit between heated platens. Each mold is shaped like the final product. A plate, a bowl, a tray, a compartment container. Workers place a prepared palm sheath into the mold. The machine closes. Then something remarkable happens. Temperatures often exceed 150 degrees Celsius. Pressure rises dramatically. For several minutes, heat and force work together. The sheath softens. Fibers compress. Moisture escapes. The material begins conforming to the exact shape of the mold. When the press opens, the transformation is almost unbelievable. The rough agricultural waste that entered moments earlier now resembles a finished product. A smooth plate, a bowl, a serving tray. Perfectly shaped, rigid, strong, ready to use. And here's the strange part. No glue was added, no plastic was injected, no synthetic binder was introduced. The factory simply applied heat and pressure. At this stage, many people assume there must be some hidden adhesive involved. After all, how could a dry, fallen leaf suddenly become a durable food container? But the answer is buried inside the sheath itself. Because the material already contains natural plant polymers that have been supporting the structure of the palm for years. Under enough heat and pressure, those polymers begin behaving differently. The factory isn't building a new structure. It's reorganizing an existing one. The result is surprisingly strong. Many palm sheath products can hold hot meals, soups, curries, oily foods, even food served directly from grills and ovens. Some products withstand temperatures that would deform ordinary plastic tableware. Others remain stable in refrigeration or freezer conditions. Yet despite that durability, the material remains entirely plant-based. The plate looks simple. The science behind it is not. But the most surprising part of the process still hasn't happened. Because shaping the plate is easy. Making it food-safe, export-ready, and capable of competing with plastic products on the global market is much harder. And that's where the hidden science of palm sheath tableware finally reveals itself. By now, the transformation seems almost impossible. A piece of agricultural waste enters the factory. A finished plate comes out. No plastic, no paper pulp, no synthetic coating, no glue. And that's where most people become skeptical. Because modern manufacturing has conditioned us to expect additives. Plastic products need polymers. Paper products often require binders. Wood composites frequently rely on adhesives. So what exactly is holding a palm sheath plate together? The answer is hidden inside the material itself. Because the factory isn't creating strength, it's revealing strength that already exists. Every palm sheath is a natural composite material. Long before it falls from the tree, it spends years supporting massive palm leaves. Those leaves must survive tropical storms, heavy rain, strong winds, intense sunlight. To accomplish that, the sheath develops a dense internal structure made of cellulose fibers, hemicellulose, and lignin. These are the same fundamental building materials found throughout the plant kingdom. Cellulose provides strength. Lignin provides rigidity. Together, they create a natural engineering system refined by millions of years of evolution. The palm tree already solved the structural problem. The factory simply takes advantage of that solution. When heat and pressure are applied during molding, the fibers compress tightly together. Microscopic air gaps disappear. The structure becomes denser, stronger, more uniform. At the same time, the natural polymers within the sheath soften slightly under heat. Not enough to melt, not enough to become liquid, but enough to help neighboring fibers lock together more tightly. The process resembles what happens when wood is compressed under extreme pressure. The material becomes stronger without requiring external adhesives. And that's the hidden truth. The factory doesn't need glue because the palm sheath already contains everything necessary to create a durable product. The raw material arrives with its own reinforcement system built in. Nature already did most of the engineering. But here's where the story becomes even more interesting. Many consumers assume these products are made by cutting down trees. After all, plates usually come from paper. Paper comes from wood. Wood comes from trees. The logic seems obvious, yet palm sheath tableware follows a completely different model. No trees are harvested. No forests are cleared. No living parts of the tree are removed. The raw material is collected only after it falls naturally. Imagine a fruit orchard where apples drop to the ground. The farmer doesn't need to cut down the tree to collect them. The same principle applies here. The palm tree continues growing. The factory collects what nature already discarded. That's one reason palm sheath products gained popularity among environmentally conscious consumers. The material exists whether the factory collects it or not. Without collection, most sheaths would simply decompose or be burned. Either way, the material eventually returns to the environment. The factory intercepts that process and gives the material a second life. But this is where marketing often gets ahead of reality, because many advertisements present palm sheath products as completely impact-free, the perfect environmental solution, the guilt-free alternative. And like most things in manufacturing, the truth is more complicated. Yes, the raw material is renewable. Yes, no trees are cut down. Yes, the products eventually biodegrade. But factories still consume energy. Transportation still requires fuel. Water is still used during cleaning. Heat presses still require electricity. The environmental footprint is lower than many alternatives. That doesn't mean it's zero. And that's an important distinction, because sustainability isn't determined by a single ingredient. It's determined by an entire system. A plate made from agricultural waste can still travel thousands of miles across oceans before reaching a customer. A factory can still operate efficiently or inefficiently. The material matters, but so does everything around it. And yet, despite those realities, palm sheath products possess one advantage that few disposable products can claim. When their useful life ends, they don't become a long-term waste problem. A plastic plate may remain in the environment for centuries. A foam container may persist even longer. A palm sheath plate simply returns to where it came from, the soil. And that's what makes this story so unusual. Because most manufacturing processes begin with extraction, mining, logging, drilling. Something must be taken from the environment. Palm sheath manufacturing begins with something that has already been discarded. Waste becomes a resource. The factory doesn't create the material. It discovers value in it. And that's a completely different way of thinking about manufacturing. The plate may look simple, but its existence challenges one of the oldest assumptions in industry. That useful products must come from newly harvested resources. Sometimes the raw material is already lying on the ground, waiting for someone to notice it. The finished plate now looks ready for a restaurant table. Smooth, rigid, natural. Every grain pattern unique. But before it reaches a customer, it still has one final journey ahead: global distribution. And that's where this small product becomes part of a much larger story. Because palm sheath tableware isn't competing against paper plates. or wooden trays, or ceramic dishes. Its real competitor is plastic, and plastic is one of the most successful materials ever created. It is cheap, lightweight, durable, waterproof, easy to manufacture. For decades, those qualities made plastic disposable tableware almost impossible to replace. Restaurants embraced it, airlines used it, food delivery companies depended on it, event organizers bought it by the millions. The system worked, at least for a while. Then the waste began accumulating. Scientists estimate that hundreds of millions of tons of plastic waste are generated globally every year. A significant portion consists of single-use products, items designed to be used for minutes and discarded for decades. Plates, cups, containers, utensils. The convenience lasted moments. The waste remained far longer. Governments started noticing. Cities introduced restrictions. Countries announced bans on certain single-use plastics. Major corporations began searching for alternatives. And suddenly, products made from agricultural waste moved from niche markets into mainstream conversations. Palm sheath tableware found itself in the right place at the right time. The product offered something unusual, a disposable item that looked premium. Unlike foam plates, unlike thin plastic trays, palm sheath products often resemble handcrafted tableware. Natural textures, natural colors, natural patterns. No two pieces are identical. That uniqueness became part of the appeal. Restaurants started using them for upscale presentations. Wedding planners incorporated them into eco-friendly events. Hotels adopted them for outdoor dining. Consumers began paying more for products that looked less industrial. Yet perhaps the most powerful selling point wasn't appearance. It was what happened after use, because eventually every disposable product becomes waste. The question is what happens next. A plastic plate may survive for hundreds of years. Sunlight can break it into smaller fragments. But those fragments don't simply disappear. They become microplastics, tiny particles that spread through soil, rivers, lakes, and oceans. Palm sheath products follow a different path. Given the right conditions, moisture microorganisms and time gradually break the material apart. The same biological processes that would eventually decompose the sheath beneath a palm tree continue working after the product is discarded. The plate returns to organic matter, not immediately, not magically, but naturally, and that's an important distinction. Many consumers use the words biodegradable, compostable, and eco-friendly interchangeably. They aren't the same thing. Biodegradable simply means a material can eventually break down. Compostable generally means it can break down into useful organic matter under specific conditions. Palm sheath products often qualify because they begin as plant material and remain plant material throughout manufacturing. No synthetic layers, no hidden plastic films, no laminated coatings. What enters the factory is natural. What leaves the factory remains natural. And that's surprisingly rare in modern manufacturing. But here's where the story comes full circle. Because the plate itself was never really the point. The real story was the material. Most industries begin with resource extraction. Trees are cut, minerals are mined, oil is drilled. Raw materials are removed from the environment and transformed into products. Palm sheath manufacturing starts with something completely different. A byproduct, a discarded material, a resource that already exists whether anyone uses it or not. The factory doesn't harvest the raw material. Nature does. Gravity does. The tree simply lets go. And that's the final reveal. The plate on your table wasn't created from a forest. It wasn't molded from petroleum. It wasn't assembled from synthetic chemicals. It started as something most people would walk past without noticing. A fallen palm sheath lying beneath a tree. What changed wasn't the material. What changed was perspective. Someone looked at waste and saw a product. Someone looked at something disposable and saw value. The factory's greatest achievement isn't shaping a plate. It's changing how we think about resources. Because sometimes the most sustainable raw material isn't something that must be harvested. It's something already waiting to be used. The plate never came from a tree. No forest was cut down. No plastic was molded. It simply fell from a palm tree and waited for someone to recognize its potential. That's the process. We reveal how things actually work one story at a time. If there's something you'd like us to explore next, let us know. Until then, trust the process.